In this video, we're going to talk about the arithmetic geometric mean inequality. Okay, it states the following. Given that A1, A2, AN are positive numbers in R, we have the arithmetic mean, which is the one on the left, which is A1 plus A2 plus AN over N is greater or equal than the nth root of the product of this element, A1, A2, up to AN. In the case when we have n equals to 2, we have A1 plus A2 over 2 is bigger than the square root of A1, A2. We know this, okay? And we have proved it many times. In fact, since A1, A2 are positive, we can take the square root of A1 minus the square root of A2. And we square that. And we know that this is a square, therefore it's always positive. And if we expand, we're going to have the square root of A1 squared plus the square root of A2 squared minus 2 the square root of A1 times the square root of A2. Okay, I had to simplify here this expression. Now we know that this one is just the absolute value of A1, but since A1 is positive, we have A1 here, and the same we have A2 here. And if we take this one to the side, we have 2 square root of A1, A2. And if we divide by 2, we get A1 plus A2 over 2 is bigger than A1, the square root of A1 times A2. So this is the case for n equals 2. Okay, and we will give a proof that we'll use some inequality that we have to prove. We're going to see that in a different video, in a separate video. Now, if n equals 3, we have A1 plus A2 plus A3 over 3 is bigger than the cubed root of the product of A1, A2, A3. Okay, so this one, the AM-GM inequality is very simple to state, but its applications are very deep, and we're gonna see. For instance, if we are asked that given that A1 times A2 times AN is 1, and we are asked to prove that A1 plus A2 plus A3 plus AN is bigger than N, how can we proceed? So if we are given this case here, with the assumption that A1, A2, and AN are greater or equal than 0. Okay, so one easy way to prove this one is to use the AM-GM inequality. So in this case, we know that A1 plus A2 plus AN over N is bigger than the product, the nth root, product of A1 times A2 times AN. But we know that this is just 1, and the nth root of 1 is just 1. And therefore we have A1 plus A2 plus AN over N is bigger than 1. This means that A1 plus A2 plus AN is bigger than N. Okay, and that's what we need to prove. Okay, very helpful. Now we will use some different notation here. So we know that we can write the A1 plus A2 plus AN in sigma notation as the sum of the AI's with I going from 1 to N. And here we can write this product A1, A2, AN as pi AI with I going from 1 to N. Doing so, we see that the AM-GM inequality becomes In this case, we will have the sum of the AI's, I going from 1 to n, is greater or equal than the nth root of the product. Okay. So this is a compact writing of this AM-GM inequality. Okay. Next, we're gonna prove it. And I think that's what we're gonna do next. Thank you.